Hello, dear committee. I'm going to show you in a brief way the summary of the progress that I achieved in the semester February to June of 2021. Okay, and my first paper of my doctoral program called Curve Layer Fused Filament Fabrication and Overview was submitted to the journal Additive Manufacturing. The submission was performed on April 17th of 2021, and today this is the current status how appears in the image. And the second goal, two different regions with different degrees of relative density were developed in the same lattice structure. However, there are a gap of separation between them. The junction between two regions was partially solved for the case of two regions only, first in a planar test sample, and after that in a geometry with a variation in the z-axis. As you can see in the image of the right side of the screen, the mandrel of the structure was not playing this curve, but it's a simple curve, it's not a very pronounced curve. New lattices were designed according to the dimensions available in the texturometer. In this case, 80 by 30 millimeters. New CAD files were generated to print and also to perform the finite element analysis according to the dimension of the texturometer, all samples. When the unit cell number is reduced, the curves appear as peaks. So it was discretized in subsegments that divided the curve trajectories in small parts. So it does not matter if the unit cell number is reduced, the trajectories will be approximately near to the original shape. Each curve was divided in subsegments in the MATLAB code. For the generation of the CAD lattices, it was necessary to create a 3D sketch and to connect manually each point of the structures to generate the trajectory that will be used as profiled in the swept extrusion operation. That was too difficult to perform manually, and maybe it caused human mistakes. For this reason, it was generated a macro in the Visual Basic console in SolidWorks that automates the process and helps to save a lot of time in the CAD design. The macro generates a profile that will be used in the swept profile extrusion. It takes a lot of time because we need only to perform the operation, and it is not necessary to connect manually each point to the next one. After that, it was definition of parameter variation for manufacturing, for mechanical testing, and for computational simulation. I'm going to make 5 different variations of amplitude in the lattices, but only the first variation will be printable according to the available space and degrees of freedom in the Cartesian printer that I have. But it will be generate another 4 variations of amplitude that will be not printed at this time, but we will be analyzing in the finite element method analysis. But the simulation and the FEM analysis will be performed in all lattices. This is the distribution of how the samples will be analyzed. Only the first one amplitude will be printable, and the 4 next ones will be only theoretical. I started the finite element analysis according for I need to perform in the 25 samples. but according to the limitation of my licensed product, it has numerical problem sizing it. So at this moment, I'm looking for another option to perform the finite element analysis because the meanwhile increment the relative density of the lattice. I mean, when I introduce a lot of number of unit cells, it is necessary to perform a mesh more fine. So a finer mesh. So I need a bigger number of nodes or elements in the finite element analysis. I am looking for options, and I also request permission to work remotely in a computer with a license of research that have a bigger number of nodes available to perform the analysis. But this analysis is in progress. Thank you.